this webinar is I'll be showing you a lot of the new things we have in SolidCAM 2016 when it comes to our general and 2.5D milling operations. But I'm not going to show it to you in a PowerPoint. I'm actually going to show it to you as I'm programming parts. And there are a lot of new features that we have in here. Some of them I've showed before, but some of them also that I have not shown before. So let's actually get started. And let's first start with the part that we see on our screen. Now I'm going to start by doing a simple face mill operation. Now note my stock has been picked already. My target already exists. When I start my face operation, you'll note the following. If I've chosen a target already beforehand, I will automatically have a geometry for my face milling operation inside. So I don't have to go in and create a geometry. This geometry is based on my target. Of course, if I want, I can go in here and do edit or create a new one, but we have as default a default geometry based on the target itself. So this is something, I know people have asked me about this, so we have this put in here now. So this way you don't have to waste time and go here, okay, let's create a new one, go in here to pick my target, and then say, okay, if I already have it, we will automatically create a geometry for it. Again, I'll just complete the operation itself. I'll choose my face mill operation, okay, and my levels, pick it over there. My technology, I prefer using always the spiral technology in this particular case. In my links, I'm going to have it as none. Just do a quick save and calculate, run my simulation, and as you can see, my tool will go down and clean it with a spiral around the part. Okay. Now, let me get to my next operation. I'd like to actually move this up a little over here. Okay. Now, I've already machined out this area over here. What I'd like to do now is work on these through pockets over here. We have this through pocket over here, this one over here, this one over here, and this one over here. Now, you'll note certain things about these pockets. The upper level of this pocket and this pocket are different than the upper level than this pocket and this pocket. You'll also note that the depth of these pockets, these two are the same, and these two go all the way down to the bottom over here. So what I'm going to do is, to do this normally in your pocket operation, you would have to do this in your two separate operations because you have different upper levels that you would be working on. Or if you do it on the same operation, there'll be a lot of wasted time because you would have areas that were already cut through where you don't have to work in those areas. So I'm going to start a regular pocket operation. I'm going to choose my geometry. I'll click on this one over here, my second one over here, my third one over here, and my fourth one over there. Okay, we have 4 separate geometries. My tool, I'm going to use in this particular case a 10 millimeter end mill. Now let's go to my levels. I'm going to use, we've had this already in 2015, but we've made some improvements here as well. When we go into our milling levels, we have the variable milling levels option. If I go into variable levels, we now have inside our variable levels the option of choosing for each chain also the upper level as well as the depth. So if I were to go, say, into chain 1, I'll say my upper level is here. Chain 2, my upper level is also on that level. Chain 3, over here. And chain 4, also over here. Now, my depth for chain 1 is going to be up until there. Same thing for 2, over there. Same thing for 3 is going to be down here. And chain 4 is going to be down here as well. So in one operation, we have different upper levels and different depths as well. Okay? I'm not going to make any changes over here. I'm just going to do a quick save and calculate. And if we take a look at the toolpath that I have over here, you can see that my upper level in this particular case starts over here, and my lower one starts over here. Let me just go back in here for a moment so we can see it a little better. I'm going to have my safety distance at 2 millimeters so we can see it a little better where the upper and lower level is. You can see that for this pocket, the upper level starts here with the 2 millimeter safety. This pocket, the upper level starts over here, 2 millimeters above this. As far as the depth goes, you can see this pocket goes all the way down to the bottom, whereas this pocket goes all the way down to here. So all of this was done in one operation using a simple pocket operation. Okay, let's continue on now. What I'd like to do is mill out this particular step over here. So I'll do that by using a profile operation. If I go into profile, we'll choose our geometry. Now, of course, we've already seen in the past that we have a new way of choosing geometries. Now, I'll go a little further into that a little later on in the webinar. But right now, I don't want to have tangent propagation or constant Z propagation because I only want to pick that one line over there. So I'll just uncheck these and click on that edge. Now, it should be known that the width of this ledge over here is a total of 15 millimeters. Now, I'm going to start off by using a 16 millimeter end mill. In other words, this end mill is big enough to cover the entire floor, although most of the tool will be engulfed by the material, but it's enough to clear this entire floor over here. We'll do our levels. We'll go to our pocket depth over there, and my upper level on top over here. And in my technology, I want to do a rough cut as well as a finish. We'll leave clear offset alone for a moment. Okay? Let's just do save and calculate, run my simulation, and as you can see, if I go into the part, let's take a top view of the part. You can see the material is being removed. You can see all the material, the entire step is going to be removed, but it's pretty much engulfed inside that step over there. Okay, we'll finish that off. It goes all the way down to the bottom, clears everything off. Now, because we don't want to take such a heavy cut with this tool, I'm going to use the option of clear offset. The clear offset, I'm going to set this at 8 millimeters. My step over, I'm also going to set it at 8. It's going to change to 7.5, so I'm not worried about that. I didn't put a floor offset in here before. I'm going to put a floor offset in here as well of a 0.5 millimeter. Why a 0.5 millimeter? I want to be very clear so you can see it very clearly on my screen. Okay. I'm just going to leave it now exactly the way it is. No changes. Save and calculate. Run my simulation. And let's zoom in to this area over here. Do it one step at a time. You can see we have our first step. We have our second step. Now we have our third step at -24. And our fourth step is at 29.5 millimeters. Now, since I have an offset of a 0.5 millimeter, we see that over here. My next step is actually going to come ahead and I'll finish the floor. Okay? So we have now a finished cut on the floor. Now we're going back and doing the next step in. You see it's still a 0.5 millimeter away from this wall over here. We still have material left over there. We're going down to this step over here. We're going down again to 29.5. And again, we're doing a finish cut on the floor. But note, this part has had a finish cut already. This part hasn't. So in essence, when it goes over this area, this has already been done. So I didn't have to do this beforehand because I'm doing it now. But it was done beforehand. We'll just continue on down. Okay, so it was done. Now, when I do my final cut, again, it went down on the entire floor. So there were 2 extra steps I did not need over there. To deal with this, we have the option of combine wall and floor passes. Let's use that for a moment. Run my simulation. And again, we'll do this one step at a time. We had our first step, second step, third step, and our fourth step at 29.5 millimeters. Now, instead of going down now and doing the finish step for 30 millimeters, it's going to go over to the next step. Again, clearing off the material. In this particular case, again, going down to 29.5. And now it's going to come back and do a finish cut on the wall and the floor together. So now when it does the floor, it does it all in one shot, this entire floor in one shot. This is good if your tool is wide enough that it can cover the entire floor. This can be useful. So we saved actually 2 steps in this particular case. Okay, now let me go back here for a moment and talk about our compensation that we have, the compensation options that we have on our left-hand side. We have options for compensation on our rough cut passes, separate also from our finish passes, and we also have the option of compensation on our clear offset passes. So if I were to check that and run my G code for a moment, we can see that already in the very beginning, as it goes down to my first clear offset step, we already have a G41, a compensation move for moving into the part. When we finish that line, we have the G40, and then again we have G41. So we have this on all of our compensation passes. When we get down towards the bottom, we can see this. Obviously, we also have it because we have our finish checked off. We also have it for our finish as well as our actual roughing operation. Now, if I were to get rid of compensation on clear offset passes, and now run my G code, you'll see in this particular case, there's no compensation inside my lines for my clear offset. But when I get towards the roughing cuts down here, we see we have G41 over here, G41 over here, and we also have it on our finish. Now, if I were to get rid of the compensation on rough passes, calculate and then run my G code, you'll see that the compensation is only on my finish pass. At the very bottom, you can see we have our G41. All the other passes are working without compensation. So you have complete control of exactly where you want your compensation. Now, by the way, all the parts will be available together with the recording of this webinar on the website together with the recording itself. There'll be a download for it as well. Now, let's now continue with side 2. This side, it's a little bit different over here. What I'd like to do is I'd like to mill out this floor area. And if I take a look at the part, we have this floor, which is at an angle, also on the other side, exact mirror of this. Besides that, we also have holes that I'd like to drill out over here. It's not on the same level. And also I have the flip level, I have it mirrored to the other side. So let's start off by working first on these floors over here. What I'm going to do in this particular case is I'm actually going to use pocket recognition to mill out this floor. I'll go to pocket recognition. When I choose my coordinate system, okay, if I'm not sure which one, I can always look over here. That's my coordinate system I want to use. When I go to choose my geometry, I'm just going to use the option of face, not the entire body, just the face. The reason why I like doing this is very simple. When I choose just the face, it already automatically recognizes what is open and what is closed. Okay, I'm going to use my tool. In this particular case, I use my 10mm end mill. And my technology, I'm just going to set my open pockets for using profile strategy. Do save and calculate. Just take a quick look at the actual tool pass itself, and you can see that we have a tool pass done over here. Now I need this mirrored to the other side. Now before I do that, what I'd like to do is I'd also like to do these holes over here. So I'm going to now use a drilling operation, and I'll choose the proper position for that. Excuse me. And when I choose my geometry, I'm going to go into just that hole over there. That's where I want my drill. Okay? The tool that I'm going to use right now, I'm just going to do a simple spot drill operation using a 3mm spot. My levels, my upper level is going to be over here, and I'm going to have my drill depth the same, changing my depth type to diameter value of this hole over here. Okay. Now, I'll do save and calculate, and you notice we have that one over there. What I'd like to do is also transform it to this one, even though it's not on the same level. So we have the option of transform, and if I go to translate matrix, you'll note that I can do my transform along a customized axis. If I choose that, I'll click on which axis do I want to work on. I actually want to work on according to this axis over here. I want to have 2 of them done, and my step over is going to be 6mm. And as you can see, it's going to go down to that level over there. Click on OK, save it, and exit. And as you can see, I have the drill done over here. Now, as I said, I need this mirrored to this side, as well as this operation over here. I need that mirrored to the other side as well. So I'm going to choose both those operations, and my mirror is done from this point over here. Right click, we have the option not transform but mirror. Now, the mirror can be done around a specific home position or a specific plane. In this particular case, I'm going to use a home position that I had before, Mac 1 position 1, which is, in this particular case, the middle of the part. Now, I have to tell it around which plane of the home position. If I do ZX, you can see that's going around this plane. If I do YZ, you see it's going around this plane over here, and that's exactly what I need. You can see now that it actually did a mirror of the geometry to the other side. I'm just going to click on OK, and we have our geometries for all of them. These holes over here as well as over here. Now, what I would like to point out also is that when I do mirror this way on my 2.5D, such as these 2 pocket operations, it keeps the cutting direction of the tool. Let's take a look just at a quick simulation of these 2 particular operations. Okay, and we'll do simulate, And let's take a look at the tool. The tool is actually working, climb cutting all the time. You can see as it gets close to the wall, you can see the climb cutting as it's working over here. This is the first pocket. You can see the climb cutting. Now, when I get now to the other side, you can see it's keeping the climb cutting direction. It's not starting from this side, it's actually started from this side now. So it's keeping the direction of climb milling. And as you can see, it gets to the end, you can see it very clearly over there. Okay, I'd like to move on now to a different part. Now, in this part again, I like to emphasize the option of our rotate and our mirror again. Now, if I were to go, and what I'd like to do first is I'd like to mill out this pocket over here. Later on, I'd also like to drill out these holes over here. Now, this pocket, will note that it's actually also rotated around this axis over here on 3 sides. This is also mirrored to the other side over here. So I'm going to start, let's do an iMachining operation. Let's do an iMachining 2D. I'm going to use an iRough plus iFinish. This way I can also finish this particular pocket. My geometry in this particular case is going to be, before that, one moment, we have our position for my pocket. We can see it over here very well. My geometry is going to be this edge over here, that pocket. I can choose this one over here, as well as this one over here. That's my geometry. My tool is going to be my 6mm end mill. Levels, upper level is over here, and my depth is up until the floor over there. Okay, we'll do a quick save and calculate. And as you can see, we have our tool pass on this area over here. Okay, but what I'd like to do now is rotate this around this particular axis that we have over here. So we'll go to our option of transformation, and we'll choose this time rotate. Rotate delta. Number of rotations, we'll get to that in a minute. Let's first go around over here, rotate around. I can do a rotate around the current position, which is not what I want, or according to a specified axis. I'm going to choose my axis. The axis that I'm going to choose is this one over here. We'll accept it. Now, number of rotations, total of 3. Start angle, keep it exactly the way it is. My angle step is going to be 90 degrees. Now note, it's going in the wrong direction. I don't have to write minus 90. What I can do is, in my custom axis, I can change the direction of my axis. And that just flips around the actual way the rotation is being done. So now we have these operations on these sides over here as well. Click on OK. Save that. And we have now our toolpath for all of them, as shown over here. Now, I'd like to mirror this to the other side. So we'll go at right-click, mirror. This time, instead of doing it around a mirror about a specific Mac position, we also have the option of doing it around a specified plane. If I go to select plane instead, and I click on the option to choose a plane, Now, I don't see the plane over here, but if I open up my CAD tree, you can see I have my planes over here. If I go, let's say I pick the right plane, which is the one I want, I'll accept that. You can see it's mirrored exactly around that plane to the other side. Click on OK. And what's actually being done right now, it's creating a new operation. And the toolpath obviously is working just as before in the right direction. The geometry is what is being mirrored, not the toolpath. So we get the correct direction that we need. And again, these are separate operations, so you can control them separately if you want. Now, I'd like to continue by going to these holes over here. So go to drilling. Let's just get rid of my toolpath. I don't want to see it right now. We'll go to drilling, and I'm going to use my next home position, which is over here. And I could choose this entire floor and take all three of these. But I'd like to actually demonstrate something over here as I'm going to do my transform later on. So I'm only going to choose right now one hole over here. Okay? The tool, I'm just going to use the spot drill. And my levels, my upper level is going to be over here, and my depth is over here. Again, the diameter value according to this diameter over here. And we have the tool pass for that particular hole, as you can see over there. Now, what I'd like to do is transform it along this direction over here, and also down here, which is not in this at the same level. So I'm going to again do my transformation, translate matrix, and I'm going to use again the option of custom axis. But this time I'm going to use two custom axes. The first one being this one over here, and the second one being this one over here. I'm actually going to choose it on purpose from the other side. Okay. Number of copies. Let's see. In the first direction, 3 copies. Distance over here is going to be 55 millimeters. You see it's going in the wrong direction. I'll just flip around my axis. I don't have to write minus 55. Just flip around my axis. Second, we have 4. And we also have my second step over is 50 millimeters. Again, since I picked it from this direction, you see it's going in the opposite direction. I'll just change directions over here, and you can see it's going now exactly where it's supposed to. And don't forget, we also have the sorting over here. So if I want, I can go ahead and sort this out and say I want this pattern instead. And you can see that over here as well. Click on OK, save it, and we have all of that done. So what we've done over here, we've done the rotate around an axis, we've done mirror around a specified plane, and we've also done transform these holes along a specified axis that we want our transform to work on. Okay. By the way, I am working in SolidCAM 2016 SP1 development. Okay. Next, I'm going to go for the next part that I want to show. And what I'd like to do, many of you have seen this part before, but I'd like to actually emphasize and show different ways for picking geometries, different scenarios of what happens when you pick your geometry. Okay, let's, for example, pick a geometry, a chain geometry going around the top over here. To do this easily, I'm just going to use the option of Profile, Geometry. We have now as I've shown before, we have our tangent propagation as our default and constant z propagation as well. If I were to click on this edge over here, you'll note that it goes all the way around over here. It's both constant z and tangent here. At this point, we have our tangent going up over here, and then back constant z. Same thing going down over here. Now, when it gets to this point, it stopped. Why did it stop? Because there's no constant z and there's no tangent. All I have to do is click on one of the blue options. Okay? Now, we have our default arrow showing it going this way. I'll just click on that line over here, and now we've completed the geometry. Okay, that was pretty simple. Let me actually go out of here and choose it again. But this time, I want to choose my geometry along the bottom over here. So if I would leave this exactly the way it is, that wouldn't be good. Because if I did that, what would happen is, it will actually choose geometry along the bottom over here, which is not good. I don't need a geometry in here. I want it to be on the outside. So let's redo that. But this time, when I redo it, I'm going to get rid of my tangent propagation and my constant z propagation. We're going to let's start by picking this line over here. Okay, now I picked a single entity. Now it's showing me what are my options. My options are this one, or this one. Now, instead of picking these lines over here, I have the option of choosing the selected element. Now, if the selected element, which is the one with the arrow on it, is not the one I want, I can change my selected elements by the next arrow below it, called change direction. As you see, let me zoom in also to this area over here. If I were to click on that, you can see the direction changes until every single time I click on it, I'll get a different direction. Okay? If this is the one I want, I could just continue straight from here without going and picking the part. Okay, we'll go along over here. I got to this point, and you can see it's going up over there. Okay. What I'd like to do now, however, I want to choose the bottom instead. So let me start now with the bottom. Okay. And we'll continue with selecting the area over here, add selected element. And now I got to this point over here. Now, at this point over here, I don't want to go in here. I could change direction and go up this way, but that's a lot of clicks. We still have these options down here. I'm going to choose, in fact, curve plus close corners. If I do that, I'm just going to go over here and click this edge over here. What do I get? You can see from the blue on top, from the projection that we have of our curve on the top plane, we see the exact geometry that we have. I want to continue on now up until this edge. You can see, again, it does that as well. Okay? Now I'm just going to go back to a regular curve. You can see the direction it wants to go in. Now just continue with my geometry. And there we have our geometry picked with a combination of different objects over here. So this is how we can actually work with the geometry. It can be as automatic as you want, or if you need to be picky one at a time, you can do that also, and it's very easy maneuvering between the two. What I'd like to do now is the following. I'd like to go a little more into our geometry, and I'm going to pick this part over here. Okay, just a moment. Okay, always happens when I don't need it. Okay, one more time. I'll start this again. I'll be right with you. Okay. I'm going to pick this part that we have on our screen now. Okay, you should be seeing it now. Okay. I'd like to create a geometry that goes around this area over here. Okay. Now, in this particular case, it's obvious that I can't do constant z, and I can't do the tangent propagation. So if I were to go to Profile and do this, New, I have to get rid of these. Now, I've been asked about why this has to always be this way. Well, what we can do is very simple. If I don't want to have those coming on every single time, I can change my settings. If I go to my SolidCAM part, CAM settings, go to my geometry, the option of default geometry, and get rid of tangent propagation and constant z propagation. Click on OK. Now when I start my operation, profile operation, my geometry, you'll note it's unchecked. If I want, I can check it now instead. So you can work any way you want. Okay, so let's start. I'm going to click on this edge over here. Now this is a perfect case where this particular button, Add Selected Element, comes in very handy. Because as you can see, if I want to start clicking at every single one of these, I have to start zooming in, start going to even these little lines over here, and it can be really, really bothersome, and sometimes you end up picking the wrong line, pick the surface. You always get mixed up. By choosing this Add Selected Element, it'll start moving along those automatically, as you see over here. Always moving in the direction I want to go without having to zoom into the part to pick those edges. And what's nice is that you can also see the actual projected chain on the work plane on top. Completed, we have our complete geometry. If for some reason I don't want to see this, we always have the option of show chain on work plane. Just get rid of the check mark and you won't see it there. But I know a lot of people do actually like to see it, so we have this here as default. Okay. Now let's get to one more part that I'd like to get into. We'll open up this part over here, and it's actually a very, very simple part. But I'd like to point out a few things on this part. I'd like to actually machine out these steps over here. Okay? Now note, a simple profile operation I'm going to do, but note that these steps are on different different levels over here. Okay? You have this one here, this one there. You have different levels over here. Okay? So the upper to here is different from here to here. Previously, if I had to do this in a regular profile operation, I would have to go to Profile. I can only do this one at a time. I pick one, click on this edge over there, say OK, choose my tool, continue with the operation, save the operation, and then do another operation for this one, then do a separate one for this one, and then another one for this one as well. What we can do now is we can do this all in one operation. We'll do the profile. And first, let's pick our geometry. I'm going to click New. Now, when I pick my geometry, I'll start by clicking on this edge over here. Now, instead of clicking on Accept the Geometry, I'm going to go to my keyboard, and I'm going to hold Control. When I hold Control, I'm going to click on this edge. Note what happens. My first geometry was accepted, and I already have now a second geometry. Flip the part around here, hold my control button, and again hit this edge. Now we have another chain already started as well. I don't have to constantly go back to click on this. All I have to do is hold my control button, and I have another geometry. Click on this one. My third one is completed. Finish my fourth one. When I'm finished altogether, then I'll click my check button and I have my all 4 geometries. We'll accept that. I'm going to choose my tool. My tool in this particular case, I'm going to use a 16 millimeter end nail. Now let's go to levels. We have our upper level, but now we have in our depth the option of variable depth. This is something we did not have before. We'll click on the option of variable depth, and we'll go into variable depths. We have our first chain, second chain, third chain, and fourth chain. So we go to our first chain, which is over here. We'll click on this level over here. You can see that chain is going to go down to 18 millimeters. If I were to click now on my second chain, we would go down to over here, 16 millimeters. Next chain, up into that floor, 14 millimeters. And the last chain, which is on the flip side over here, 20 millimeters. So we have all our depths in one operation. So instead of doing this in 4 separate operations that we did before in Profile, this can now be done in one operation. Okay? We have our, obviously we have our technology, we have our rough cut, finish cuts, all of this is available just as before. Let's do save and calculate. Let's just take a look at the actual toolpath that we have over here. You can see that the toolpath goes down to the level of each one of those floors over there. All done in one operation. Now, to finish this off, I'd like to work inside this pocket. Now, I want to go over one of the things we did last week's, that Anthony did in last week's webinar on iMachining 2D. And I'd like to actually machine out this area over here. Now, note I have a hole over here. I'm going to first do a drill operation. The first time I'm going to do a drill operation, I'm going to go all the way through the hole. Okay? So I'll do a simple drilling operation for now. We'll choose my geometry on that floor over there. Okay. My tool, I'm going to use an 18 millimeter drill. Levels, my upper level is over here. My drill depth is going to be down to the very bottom over there, where the full diameter will go out through that hole over there. Of course, we have a technology. I'm not going to get into that for now. We just have our simple drilling operation done over there. Now I'm going to go to iMachining 2D. Excuse me. We'll choose our geometry. My geometry in this particular case is this edge over here. We'll just do, you can see I had to pick it this time because I have my settings set at not to have this automatically. Can work this way as well. And let's start off by using a 10 millimeter end mill. Okay. My levels for my iMachining is going to be up until that floor over there. And if I go into my link, you'll note we have the pre-drilling. I'm going to use the option of pre-drilling. And so I'm choosing that drill that I did before. Save and calculate. Let's run a simulation. And you'll see, actually, let me do with the solid verify so you can see this a lot better with the material. You can see that the tool goes all the way down to the bottom, right before the bottom. The actual bottom is 15 millimeters, 14.7, so 3 millimeters above the 3/10 of a millimeter above the bottom. It went directly down because we have a through hole over there. Okay? And then, of course, it does the rest of the eye machining operation. Now, let me stop this for a moment. And I want to go back to my drilling operation. This time, I'm going to make a change on my levels. My drill depth is going to be up until that floor only, and the cutter tip. In other words, the hole now has a spot left at the very bottom. If I were to go into this operation, recalculate, run my simulation, you can actually see that our hole this time is only going to this area over here. So we have, if we take a look from the side, this whole area over here where it hasn't gone down to the floor yet. So the tool has to actually clear that away. Let's do this one step at a time. The tool will go down only up until that level and then start going down with the helical move into the floor over there, clearing away the hole, and then continuing on with the eye machining tool pass. Now, I'm going to make a little change in this operation. Instead of using a 10 millimeter end mill, I'm going to change this to a 16 millimeter end mill. It's still smaller than the drill that I have over there, but take a look now what happens when I use this end mill. Now, it's going to go in, and it's going in through the center. However, note, when it gets to Z level, towards the bottom, to do the helical entrance to the floor, there's really not enough room for any kind of clearance over here. No, this is too small of a circle to already start helical down into the part itself. So what we do at this level is as follows. It'll actually widen that area with a spiral cut in eye machining, and then when it gets to the circle where it has enough room to actually helix down, it'll start working its way down into the part as you see over here, doing a helical cut into the part, and then continuing with the eye machining cut over here. Okay. Okay, that's more or less what I wanted to show you in this particular webinar. Just to review what we've done over here, we've showed you, working our way backwards, the option of what happens if you change the depth of the drill, if it goes through or if it goes only up until the tip, if the tool is a smaller tool or a larger tool, how it reacts, how eye machining reacts with both of those tools. We've also shown the option of how to, excuse me, of choosing geometries, all the different ways you can choose your geometry. We've shown the rotate around the axis. We've also shown the transform around the specific axis and mirror around the plane, as well as all of the different level issues, such as the upper and lower levels in the pockets, where we can have it now separate, and in the profile operation, we've also shown separate lower levels as well. Okay, I'm going to go through the questions. And as I said, as far as the webinar parts, they will be available as soon as the recording of this webinar will be posted. They will be available as well. I was also just want to let everyone know the actual machine that was used, by the way, in the trade show in Bilbao was a 5-axis Mitsura MX520. Okay, that's basically it, Eddie. If there are any other questions, that's basically it.
Yeah, we have here a question, Sydney. I see one technical question is about to show the procedures, trace level 5 of matrices drilling.
Well, okay. I'm not going to go. I'm actually not going to do that. I just because I would go. I'm not going to start opening up the post processors and doing the trace levels. But when I do have these parts available, they'll be available with the post processor, and then you can take it and take a look at it as you open it.
Thank you very much, Sydney, and thanks to all of our attendees today. We will meet you again next week. Have a nice weekend. Thank you, guys.
All right. Take care, everyone. Have a great weekend.
Thank you, Sydney.
Bye-bye.